All right. Shortly after this class, I'm going to post your midterm grades. I've graded everything. We have exam 1, and I think up through homework chapter 5 will be included. And midterm grades, however they come out, if I think you put effort in, I might bump it up, if maybe your grade was a F or a D, I might make an effort judgment and bump it up 1 grade. Midterm grades are what they are. They don't count for anything. I think sometimes the sports coaches will look at it probably more. First of all, if you're not happy with your midterm grade, you have 6-7 weeks to fix it, and you got an exam on Thursday, and we'll talk about the exam as soon as I'm done with this little speech. So it's really what you want to do with it moving forward. This class does require more effort on a daily basis than other classes, and it's like a language class. If you don't learn something, if you don't learn this normal distribution stuff that we're kind of doing it and kind of get a hang for it, the next couple of weeks are going to be not as easy to learn. It won't be impossible, but not as easy. So let's see where the grades come out, and if on Thursday, well, probably next week or Friday, if you want to have any kind of conversation with me about your midterm grade and what you can do to get a passing grade. I think, does a D get you out of this class and fulfill your requirement? I don't know. I think a C is better. So I would, if I were wanting to get the ticket punched and move forward, I would shoot for a C if you're not doing well. That being said, there's probably a mess of people that are going to get B's on their midterm that are like, I don't get B's, I get A's. And they're going to probably want to ask me the same kind of question. What can I do to get better? So that's that. Let me look at one time. The attendance again, who might have shown up that was marked absence. He's not here. Alfredo is here now. And Cordelia's here. Madeline is still not. Kate is not. Okay, we're all set. What I want to do then is share my screen. And I think the thing that people are most interested in at this point will probably be this little thing right here, exam 2. Let's make that big. The exam 2 will consist of 2 problems from exam 1. Contingency tables and the colored balls in a sack. Do we remember those problems? So that's the review problems I'm going to put. I give you a table with the number of people that, and we can do one of the problems from either. And then let me go through this and then we'll look at some problems. Then you should be able to explain the following distributions in your own words. And mostly the ones that need explanations are the discrete distribution. I mean, uniform, binomial, Poisson, geometric, probably discrete distributions are probably where I'm going to ask those. I haven't done the exam yet. That's something I have to do this afternoon as well. So I got a busy afternoon ahead of me. The normal and exponential, I may have you do problems. Now, I'm not going to have you, it's going to be pencil and paper and calculator exam. So I can't have you calculate all the probability distributions. I'm going to give you all the numbers you need in a table. Like I'm going to do the printout. I'm going to do the Excel work for you and expect you to do the, what's the probability of this? What's the probability of that? And what's the probability of a, you know, and I'm probably not going to have you sketch it like the textbook did, because I think people got confused by the difference between sketching and graphing. But it's always better to sketch it so you know what you're looking for, and make sure if you sketch the right thing and you have a wrong answer, I can say, I can give them half credit because they sketched the right thing and gave me the wrong answer. Or they gave me, but then you run the risk of sketching the wrong thing and giving me the right answer, which again, I'm probably going to take some points off that. Yeah, and in fact, for the normal, I said you have to do it. Problems on the following distributions where you're given the PDF for discrete distributions only and a CDS of the various numbers you will need to answer questions. And I'll probably give you more numbers than you need. For the binomial, the geometric, and the normal. And also, I'm going to give you, you know, in this, explain the distributions. I don't know if I'm going to ask you to do all of them. I would count on being asked about the binomial. And then you might get Poisson or geometric. Uniform is too easy, so I'm probably not going to do that. So you got to probably know what a Bernoulli trial is. And you probably got to explain the binomial distribution and either the Poisson or the geometric. That's the way I'm kind of looking at it right now. And then I'm going to give you some problems, some story problems. Like, you know, in the book, when you did the problems on the binomial and geometric, you knew what kind of distribution was involved because it was under the heading binomial problems, you know, on the section binomial or geometric. I'm not going to put it in a section. And the normal one is probably not going to be hard to do either, because well, if I give you the CDS, you're going to know exactly what it is. The other one is short answer questions. Understand and answer questions about the empirical rule. And what is a PDF and what is a CDF? I'm going to have 10 problems easily with this. What is the difference between a PDF and a CDF? The answer will be closed book. If you need a formula sheet, I will provide it. And you can use the calculator, it has no Wi-Fi. So, what kind of questions do we have here?
Do you think you could like send out like what the problems are going to look like for like the pen and paper, or is it just going to be like the same but minus Excel?
Like a binomial problem or one of those where I give you the CDF and PDF?
Yeah, that one.
Okay. Sure. Let's look at a normal distribution one. I seem to like that oven problem, don't I? Insert. And I'm sorry I didn't have a pre-exam for homework to give you, but that's my fault. You're probably happy you don't have more homework to do either. Also. Okay. the length of a crankshaft at XYZ automotive.
Yeah.
I didn't, I'm sharing it. Yeah, I know. Watching me type is not fun. Is normally distributed or has the following distribution. X tilde normal with crankshafts. Those are going to be pretty accurate. 10 comma, and let's make it 2. And so it can't be crankshaft. It has to be the height of tomato plants at XYZ nursery. Have the following distribution, where all measures are in inches. So it's normally distributed with a 10 inches of height and a standard deviation of 2. So let's say I do X and I do, I don't know, 4 equals that plus 4, not that plus 4, that plus 0.5. And I just take it all the way up down to here. And so I've gone from 4 to 15.5 inches. I should go to 60. So I've done plus or minus 3 standard deviations, and I've done it for what? In half-inch increments, which means every question I ask you has to be in a half-inch increment. So if I give you a table for CDF and is equals norm dot dist of X, what's the mean? 10 inches. What's the standard deviation? Is 2 inches. And I want cumulative. So, and I do it to 4 decimal places. It's just like a table. And I give you all these probabilities. And I make it bold. And I make it look pretty. So rather than making you calculate this, because you already calculated these kinds of things on homework, it's not an we're making it non-Excel based. So I got all my borders there. A. What is the probability that X is greater than 7.5 inches. B, what is, what is the probability that X is 8 to, let's say, 12 inches. I can't give you the invert. I can't give you the and C. Let's do this. Maybe I'll make another one. Let's make another one. Make it an easy one. What is probability that X is less than 11.5? So this will be B, this will be C, and this will be D. What is the probability that X is less than 6? God, I can't type, sorry. Still can't type. Or X is greater than 12. So let me bring this chart where you can see it. Can you do this problem? Every number you need is on this table. Are you working on it, or do you have questions, or does this confuse you? Does this what?
Can you work through the problems and give us the answers to them?
I will. I'm letting you try it first. Because guess what? On Thursday, you have to do it. We just had a homework that was due on this stuff. We did it in class. First question. Here, and don't people that know it answer it. This is for a question. What are the types of problems we have for this? We can have a tail problem, one tail, a right tail, a left tail. We can have an in between or both tails. Yes, no. So what kind of problem is this? First one, A, X is less than 11.5 inches. I gotta get my little drawing thing out, I think. Did you see the other video I made with the graphic? Draw this. For these four things, sketch those little pictures. Is it an upper tail, a lower tail, a left tail, a right tail? Is it an in-between, or is it the outside tails? What is A? Not this A, this A.
A left tail.
Who said that?
Me, Joy.
Thank you. Yes, it is a left tail. What's B greater than?
Right tail.
Who said that?
Me again.
Okay, you can stop answering now. You've done very well. What is C? What is C? Look at this. 460 less than X less than 470. So I'm calling it an in-between here. Why would this be any different? The numbers are different, but why would it be any different? Would it? It's an in-between. And if it's less than 6 or greater than 12, what is that? And why does this problem ring a bell? It's not the in-between two standard deviations. And why does these two problems, C and D, ring a bell? I'm not doing anything until someone answers this other than Joy. What's the mean? What's the standard deviation? Is this not in between one and one standard deviation? Is that not the empirical rule? Is the empirical rule tells us what's in any normal distribution, the area between -1 and +1 standard deviation of the mean is what? Me doing this problem doesn't do you any good. You doing this problem will do you some good. I did the hard part. I calculated all the stuff for you. All the numbers are here to answer all these questions. My contention is for C and D, you don't even have to use the table if you understand the empirical thingy. Yes? No? What? Anybody want to put their answers in the text or email them to me? What's the empirical rule? Do I cover this stuff and lecture it just for my own edification? Sure, I'm happy. It reminds me of stuff. That's not it. I just sketched these. Oops, I didn't put the mean on D, sorry. Are these sketches accurate? Did I not spend the entire last lecture talking about this? Eleven and a half is greater than the mean. So I drew the 11 and a half, bigger than the mean, which is at the top of the hump of this normal distribution. It's a normal distribution because I said it's distributed n, comma 10, comma 2. What's the 10 mean? That's the mean. What's the 2 mean? That's the standard deviation. So I want this probability. What is a CDF? What is a CDF? The CDF is these kind of left tail probabilities. So if I go, the answer to A is right here. It's 77.34%. That's what CDF means. This is like covering lots of the exam on one problem. 77.3% is the answer to this. And you can write it as 77.34, or you can write it as 77.34%, however you want. What's the answer to this one? Golly gee whiz, there's 10, 7.5 is less than 10. I want it to be greater than 7.5. It's the probability of the plants being larger than 7.5 inches, which means it's an upper tail probability. The CDF is all lower tail. So there's 7.5. Oops, sorry. Right there. Well, this is going to be 1 minus the probability of what? In fact, if I want to do it this way, I could make my life even easier. But I'm not going to. I'm going to make you do it that x is less than 7.5. And why is that the case? Why is it 1 minus the less than? Because I want this space, but my CDF gives me this space here, right? Shake your heads, yes. Yeah. If I add these two together, they equal 1. That means that the two probabilities, the less than 7.5 and the greater than 7.5, are what we call complements. It's 1 minus it. So if I do 1 minus CDF, and I'll just do all those calculations right now, equals 1 minus this. Oh, golly gee whiz, look at the probability of being greater than 16, which is plus 2 standard deviations, is the same as being less than 4, which is 0.13 standard deviation, is also 0.013. It's why does that happen? The normal distribution has what they call, what's that word? It starts with the S. And ends with tree.
Symmetry.
Thank you. So what's 1 minus the probability that it's less than 7.5? Here's 7.5. It's 0.894. That's not right. It's 8944. And it equals 89.44%. What's the probability of being between 8 and 12? How do we get an in-between when we only have a CDF? And remember, I'm only going to give you this part on the exam. I'm only going to give you this part on the exam. I just did this now for my own ease of calculation. I'm only giving you this part, the yellow part. How do I calculate that? What did we say last time? Why did I say it if you're not going to know it? This class is like a language class. If I teach you something last time, you should know it this time. What is that? What onus does that put on you between last time and this time? It's like a Spanish class. If I teach you the colors on last Thursday, this Tuesday, I expect you to know the colors. I'm going to say things like negro and azul and blanco, like you should know what they are. And in between is the probability of the larger CDF, the less than, the lower tail, minus the probability of X being less than the lower tail of the lower tail of the lesser number. That's how in-betweens work. And if I could type, this wouldn't be such a horrible thing. So what does that equal to? Well, that is this number, 8413, minus this number, 1582. So what is that? I don't know. You have to use a calculator. Luckily, I'm using Excel. So I'm going to say equals, I'll just do it here, equals that minus that. And what do you get? 68.27. What is 0.6827? What's the empirical rule say? What's the area between plus 2 standard deviations and minus 2 standard deviations for any, or 1 standard deviation for any normal distribution? What's the area in between the two? What was that?
1.
No. The area under the entire curve is 1. The total probability of going from minus infinity to infinity is 1. The empirical rule, did we cover or did we not? Empirical rule. Look at this picture. This is statistics by Jim versus statistics by me. It doesn't matter. Between plus and minus 1 standard deviations, it's 68, approximately 68%. Between 2 standard deviations, it's 95. Between 3, it's 99.72. If this is 95 for 2 standard deviations, what are the tails going to be? The lower tail plus the upper tail. Might it be the complement of 95? 1 minus 95? This is not that hard. That's what I have right here. What's minus 2 standard deviations from 10 when a standard deviation is 2? It's 6. What's, oh, I only made it plus 1. I should make it plus 4. That would have been better. Sorry. That's my bad. What should this be? Well, less than 6 is 0.0228. Greater than 14 is, well, less than 14 is 0.9772. Greater is 0.228. It's the same flipping number because it's 2 standard deviations. 0.0228. What is 0.0228 plus 0.0228? I don't know. I can figure it out. I'll just write it here. Equals that times 2. It's 4.55. 0.0455. If I round 0.04455 to 2 decimal places, what do I get? 5%. Empirical rule. Might you want to memorize the empirical rule? Does it apply to any standard deviation or any normal distribution, any mean, any standard deviation? Yes or no?
Yes.
Thank you. I'm not moving until someone answers questions from now on. Let me write another problem like this, right here. Blah, blah, yada, yada, x, tilde, normal, I don't know, let's call it 30 and 4. I'm going to go off screen for a second. I just want to create a problem that would be kind of interesting for you to do. So in other words, blah, blah, yada, yada. It doesn't matter what, if it's a nursery and it's a length, it's a height, it's a weight. I'm just saying something has a distribution, like it's a normal distribution with that, whatever that is, 30 with 4. So let's see, what do we got here? Okay, sorry about that. That's how long it takes me to create a problem. Let me share my screen. How long, what's the answer to this questions? All units are in kilograms. If you have Excel, you can make a table like I did, if you wanted to. Do I need a table? Do I need a table?
Yes.
I think it's that. I think it's that. I think it's this. How did I do it so quickly? Well, I made the problem, so hopefully I did it right. What are the z-scores of all these numbers? What the heck's a z-score? Do we recall? Let's make it this way. Let's say it's n 10, 2. And this is x, and this is the z-score. What's the z-score? And we have, what are the numbers here? 11.5, 7.5, 8, 12, 6, 14. How do we calculate the z-score? Z-score is equal to parentheses, in this case 10, x, which is going to be that number, minus the mean, which is 10, divided by what? The standard deviation, which is 2. So I get 0.75. And here's my z-scores for all of this. The z-score is the standard normal distribution equivalent, 0, 1. Yes or no? We have vague recall of that. Let me do the same thing over here. Let me do it again. Copy, let's paste it over here. But instead of 10, 2, I'm going to do 30, 40. Or 30, 4. A normal distribution with a mean of 30 and a standard deviation of 4. I only need one of those. And what are the numbers? 33, 33, 33.4, or 34.6, I'm sorry. All right. That can't be right. I did that wrong, but I'll fix it in a second. Let's do the other ones. 22, 38, 26, 34. Well, how do we do this? Equals, what's the z-score here? Minus the mean, which is 30. The whole thing divided by 2. 1.5 and so what do I want this one to be? I don't want it to be 34.6. I want it to be equal to 30 minus, or plus, I'm sorry, that's my problem. That's where I messed up. Times standard deviation, which is 4. So it's got to be 25. No, it can't be 25. Okay, 7. This is not right either. This should be points. That's right. That's right. That's right. That's right. Okay. There we go. It's not divided by 2. It's divided by 4. Oh, and I mixed them up. I did it backwards. That's okay. These are different. These might be slightly different. The first two answers, why the first two answers the same? Because the z-scores are the same. The probabilities of CDF of all these things will be the same. It doesn't matter. It has to do with standard deviations away from the mean. That's what the empirical rule tells us. This is plus or minus, this is plus or minus 1 standard deviation. This is plus or minus 2. So what's this one going to be? I don't know. What's plus or minus 2 standard deviations? What's in between? It's the empirical rule. What's the empirical rule say? Approximately 95%. So if I want to just approximate it, I could approximate this as 95%. What's the plus or minus of 1 standard deviation? What's the tails? It's plus or minus 68. Well, what's 1 minus 68 over 2? No, it's just going to be 1 minus 68 anyway. What's that going to be? Is that 32? If I want to make it to more decimal places, I could figure it out. The in between of 2 standard deviations is equal to that minus, no, I got the wrong thing, equal to that minus that, 0.95 exactly. This is not 0.32. If we were to make it differently, it would be 0.22. Well, let's leave it at this. It would be this, twice this, 0.1. How do I know this? Well, first of all, I wouldn't trust me, so I'm not good. I get 31.73. Which, if I take it out a couple decimal places, 0.3173. could I give you another problem that would have the same answers as this problem or this problem by just changing? I could change the story around. I could do that. And I can give you a table that has all the numbers in it. What's the probability that I will do that? What's the probability that I will do that? All right, let me ask a question here. Who feels like they would be ready to take an exam on Thursday? Raise your hand, or raise your hand if you're dreading taking an exam on Thursday on this material. See how many honest people are here. Okay, the vast majority of you are. What if I was to make the exam on next Tuesday and I come in on Tuesday? We have a class in face-to-face. It can't be any later.
Sounds like an excellent idea.
Okay. Who's feeling motivated to study a little bit? Also good. Because a little bit, I'm getting a little frustrated at two things. One, my ability to teach you, which I hate that kind of frustration. And I equally hate the frustration that you're not maybe studying hard enough this material. Okay. My job today, instead of writing an exam, will be to give you a mock exam, which is your homework, which is due. I would try to get it done by Thursday for class because we'll go over it in class. And the mock exam will function as a as a model of what we're going to have the exam on, okay? All right. Can you make these kinds of sketches? Can you make the sketches for this problem? Now, does it matter what the story is, really? Let's say I change the story. Dilithium. No, let's put it this way. Flux capacitors vary in weight per the following. distribution. All units are in kilograms. It's the same problem. Does knowing that it means that flux capacitors are the subject matter? Not at all, does it? What is a flux capacitor? Google it and answer me that question.
Is it the thing from Back to the Future?
Yes, it is.
Period.
Good for you. It's the thing that made the time machine in Back to the Future work. The car turned a DeLorean car into a time machine. So it's a fictitious thing. I was going to use dilithium crystal. What's that? I could use that in a problem too. Or dilithium sphere. Isn't that the fuel source for Star Trek? It doesn't matter what it is. The normal distribution has all this stuff together. Okay, let's go to another problem. Let's look. Have we beat normal distribution to death here? Are you understanding how? Here, calculate the in-betweens of the, what are the actual distributions of this thing? Of the empirical rule. Make them all to 4 decimal places. How would you do that? Let me make a new one. Let me get, delete, and go away. Delete. This is problem 1. Empirical rule. So this will be N 0, 1, standard normal distribution. Here's X. We go from -3 to, and we're going to increase it by 1 to +3. CDF. What does the CDF really mean? It means the probability that big X is less than little x. So the big X random variable is less than little x. Let's put it this way. Let's make this a little bit bigger. All right, so what do we have? Equals norm dot dist of.
Professor, we can't see your screen.
Sorry. Thank you for telling me that. I'm glad you didn't waste longer. a 3, a mean is 0, a mean is 1, and we're doing, when we use, oh my God, all these numbers. So let's take them all down to 4 decimal places. Okay? What's the probability that minus 1 is less than x? And I guess I should use big letters. 1. What's the probability that minus 2 is less than, so it's between 2 plus or minus 2 standard deviations. What's the next one? The probability that 3. Well, are these all in-betweens? Are these all in-betweens?
Yes.
Thank you. They're all in-betweens. How do I do in-betweens? I take the probability of the bigger minus the probability of the smaller. 0.6827. They have 6.8. Now you know it's 6.827. What's the probability of this? Take the probability of plus 2 standard deviations, subtract the probability of minus 2 standard deviations away from the mean. 9.545. What's the probability of 3 in-betweens? I take 9.987 and subtract off minus 3. 9.973. So this is the in-between. What are the tails? Well, it's 1 minus that. Equals 1 minus that. Equals 1 minus that. Just copy it down. Part of what we do in statistical inference is this. If we take something that we know has a normal distribution and we find out it lies in this tail area, there's only a 0.27% chance that that happens if this is in fact the real distribution. So if we end up with an observation that ends up here, we could say we're going to use that as evidence to say, since it rarely happens, that that's not the distribution, and we're going to reject the fact that it's a normal 0, 1, and it's probably something else. The mean is probably something other than 0. That's how statistical inference is going to work. And if we ever get to it, we'll be covering that at some point in the next couple of weeks. But we keep slowing down because I'd rather have you learn what you learn well or better than to try to jam stuff down your throat. I will promise you this, though, after the exam on Tuesday, the pace is going to pick up. It has to pick up or we will not cover what we need to cover in this class. Clear? Do you need to memorize this? Or do I need to say it? Now, let's try something else. We're going to really focus on a normal distribution here in this whole class. All right, hold on. Very important phone call here. My grandson. All right. I don't know. Should you memorize this? Should we memorize anything? I could give you this on an exam, and you can figure out these, or I can just give you these. This is the empirical rule. Does it matter the distribution? Here, let's try this. Mean equals, and let's add something here. Insert, not delete. That's the wrong way. Let's insert a couple rows. I used to be good at this, by the way. Okay, insert mean standard deviation. Pick any mean. I don't know, 1,000. What's the standard deviation? Let's make it some stupid number, 34.7. Here's X. Here's the CDF, which equals, what does the CDF equal again? Maybe we need to keep saying this over and over again until we learn it, that the random variable is less than this observed value of little x. Okay? And I want this number to be x, let's see, the mean minus 3 standard deviations. And let's pull this down here like this. No, it didn't like it because I didn't make the mean fixed. Mean minus E2. Okay, let's fix the whole formula before we do this. You should play with this at home. And this is being recorded, believe it or not. Ugh. So it's equal to the mean. I put a $sign in between there, so I hold the mean fixed, minus that number, minus 3, times the standard deviation, which is also, let's put a $sign there. There we go. It can't be minus, it has to be plus. Because if the number's negative, it comes out right. Okay, there we go. Now let's just do this. And let's make it all one decimal place. Now, if I do the probabilities, norm equals norm dot dist of this observed value, comma, the mean, comma, the standard deviation, comma, 1 for cumulative, and I put a $sign there to keep the mean fixed, and I put a $sign there to keep the standard deviation fixed, and I copy this all the way down, and I make it 4 decimal places. Do I get the same standard deviations? Or do I get the same probabilities? Is that crazy or what? That's what the empirical rule says. The in-betweens will be this for no matter what the distribution. You want to change this and make this 1,275 and a standard deviation of 3,000. All these numbers change, but the probabilities are going to stay the same. Minus 65 and 2.77. The x's change, but this is minus, if I was to calculate the z-scores for these things, let me put z-score. How do we calculate z-score? It equals the observation minus the mean divided by the standard deviation. That can't be very good. It doesn't look like I did it well. Divided by the standard deviation. And if I put a dollar sign to hold the mean and the standard deviation fixed, which it should be, what do I got? I get the same thing as a standard normal distribution. So pick some numbers. I don't know. Let's pick something evil. 666. What's the standard deviation of 666? I don't know. 9.99. These numbers change. The probabilities in the z-score stay the same. The in-betweens and the tails are always the same. Is this making some sense?
Yes.
Thank you. Do the sketches make sense?
Yes.
They're not graphs. They don't have to be exact. They're just giving me an idea that you know what you're calculating, whether it's a lower tail, an upper tail, an in-between, or both tails. In the empirical rule, it all has to do with the number of standard deviations something is away from the mean. That's the z-score. We should probably post this in this week, shouldn't we? Are your brains full? Or should I torture you for another 18 minutes? This is the interactive part of the class. Come on. How about you ask me questions about what we just did? Let's do that rather than me talk. Come on, too much silence. You want me to do something over again? Or should I just let you go? All right, let me ask this question. And you can go after you answer the next series of questions. What's a Bernoulli trial?
It's like a trial with only like two options, and it's like correct or incorrect.
With a fixed probability, right? Is flipping a coin a Bernoulli trial?
Yes.
Okay. Is rolling one dice and getting one of the options is getting a 1 or 2. The other option is 3, 4, 5, 6. Is that a Bernoulli trial?
Yes.
Thank you. It is. If I do something with a fixed probability in a Bernoulli trial and I do it like 5 times, let's say I do that dice experiment 5 times, what kind of distribution is that? And I count how many, and success is getting a 1 or 2. I guess I'm going to use all the time today. All right, let's go here. I'm not going to name the sheet yet. Okay, I think I'm sharing my screen now. Insert text box. Okay. We roll a fair dice. Die. We consider getting a 1 or 2 as a success. Otherwise, we consider it a non-success. You can call it a failure if you want to. We do this 5 times. A row. The number of successes has what kind of distribution? What kind of distribution does it have? While you're contemplating that, let me copy this right over here. That's not what I want to copy. I want to copy this. Wonderful. Let me just insert another text box since I can't do it. Okay, here I just changed it, the problem a little bit. What kind of distribution does this experiment have? Come on. The answers to these questions is between you and lunch. I know it's ancient history. We did this 2 weeks ago. Let me ask an even basicer question. Sorry for using the word basicer. Is this a discrete or continuous distribution, these distributions? Say it louder.
Discrete.
Discrete. How many discrete distributions have we talked about? Can you name them? Do you think on the exam you would recognize which distribution these are? Well, no need to answer it. These questions will be on the mock exam. These 2 questions will be on the mock exam. Let me fix this a little bit. What is the distribution? What are the parameters? What is the distribution? What are the parameters? Yay. Same basic, what's this first part? What is this? That's a Bernoulli trial. 1 until we get the first success. And the other one, we do it 5 times in a row, and we count the number of successes out of 5. All right. With that, I'm going to let you go. I'm going to hang on. If anybody wants to ask questions, they're more than willing to stay. And I'm going to stop the recording now and allow you to